So we're looking at the 2019 free response question number 1, and I want to just start by getting what are some of the main ideas and what are some of the cues that lead us to those main ideas, and then what are some of the calculator techniques that we have with it. So I'm assuming you're pretty well familiar with this question, and if you're not, familiarize yourself with it now. And then, so let's see what we can get out of here. So we have things entering and leaving at certain rates. Right? And then basically that's all they give us in terms of the givens. So in our givens, we have a rate of something entering and a rate of something leaving. In this case, it's fish. It could be, fluid. It could be potatoes. It could be anything, right? So we have rates of things entering and rates of things leaving. So what we want to be thinking of is they gave us f prime for some function, capital F, which is the number of fish in the lake. And that f prime is going to be the rate of increase minus the rate of decrease. So these could be water in a reservoir. It's inflow minus outflow. It could be money in an account. This is, revenue, and this is costs. So anything that is describing an increase and a decrease, we're going to subtract them to get the rate in question. All right. So then, look at what kind of things they are asking you. They're asking you how many fish entered the lake, what is the average number of fish that leave the lake per hour, and when is the greatest number of fish, and is the rate of change of the fish increasing or decreasing. So in terms of our questions, we're asked how many or how much of something when what we are given is a rate. So we want to be thinking about that accumulation formula, f of b equals f of a plus integral from a to b of f prime of t dt. They asked us the average number of fish. So if we just saw this average number of fish, so average number of fish would be 1 over b minus a times the integral from a to b of f of t, where f is the number of fish. All right, but they didn't really ask us what the average number of fish is. They asked per hour. So they're actually asking for an average rate. So look out for the fact that it looks like they're asking for an average number, which would be this formula, but in fact they're asking for an average rate. So average rate has two ways that you can write it. So one is we can use the same idea for average function value and say, well, since it's a rate, we'll just do the average function value of the rate. All right, so it's 1 over b minus a integral a to b of f prime of t dt instead of f of t like this one. So this would give you the average number of fish. This gives you the average rate of fish. All right, but another way that we do average rate is with the slope formula, f of b minus f of a over b minus a. So we would use this formula, the slope version, if we knew the total number of fish at the beginning and the end. And we were going to use this one if we don't know the total number of fish, but we know the rate of change. And that's what we have in this case, because the given is a rate of change. We don't know how many fish were there at the beginning or there were at the end, so we can't use this formula. But there's interesting correspondence between all these. This is your average rate of a change of a function. So if I want the average rate, this is the average value of a function. So if I want the average rate of change, I just do the average value of the rate. And then if you think actually about fundamental theorem of calculus, this integral is equal to f of b minus f of a, where f is an antiderivative of f, so that's f of b minus f of a, and then the b minus a just goes in the denominator. So actually this formula for using average function value on a rate of change, combine it with the fundamental theorem, and you get the same slope formula that everything seems to come back to in calculus. All right. Another thing that they ask us about is the greatest number. You have to be really careful. They ask the greatest number of fish. Typically, you have to break that down into a lot of parts. What you're really doing is an optimization on a closed interval. That means the key things you need to do are identify the critical points and check the end points. You need to look at what's happening at f of 0 and f of whatever their end of the interval is, which f of 8 in this case. All right. And then make a table of values of the critical points and the end points. Watch out, in some problems, they have piecewise functions for the derivative. So this would look like instead of having a constant rate of inflow and outflow, they'll have a constant rate of inflow, for example, and then they'll say something like, after 4 hours, a machine comes in and starts removing fish, something like that. So there could be a discontinuity if there was a piecewise function, and if there's a discontinuity in the function, then that's going to be a non-differentiable point. So that could also be a critical point. So if look for something like at at a certain time, the situation suddenly changes. They bring in a machine, or people start fishing, or the ride opens, or whatever. Something changes the rates of things happening. That's also going to be a critical point. It goes in your list of critical points. In our problem, that doesn't happen. We just have fish coming in, fish going out, and there's no changes at any particular time. So we're going to follow these steps to get the optimization. Then the last question asks about whether the function is increasing or decreasing. So you have to watch out between, are they asking if the amount of fish is increasing or decreasing? In that case, f prime is greater than 0 means the amount is increasing. F prime is less than 0 means the amount of decreasing. But look what they've asked here. They ask if the rate is increasing or decreasing. Not the number of fish, but the rate. Is the rate increasing or decreasing? So that tells us that since we're looking at the rate of increasing or decreasing, we're going to look at f double prime, which since they gave us f prime, means we're going to have to look at the derivatives of these two functions. All right, so rate increasing or decreasing, we need to look at f double prime. Is it positive or negative? And then some of the calculator techniques that are advised here. Since we have these two big weird functions and we're going to have to do a lot of things with them, we want to put them in as y1 and y2 in our calculator. Maybe if you label that in the problem, that way you won't forget as you're going through, which one was y1 and which one was y2. So we're going to use our y variables. We're going to use a stored value from the graphing window. We'll see that happening when we do the optimization. And another thing is, remember that I said we're going to have to do the derivatives of these two functions at some point. We're going to do derivatives and integrals, but this is a calculator active problem. So we're not going to do any derivatives or integrals by hand. You could do both of these derivatives, but we're absolutely not going to. We're just going to put them in the calculator. And I think that for our modified test format, they're going to be all calculator active because there would be no way for them to monitor otherwise. So they're probably both going to be calculator active. I'll verify that as soon as I know, or you might not. You might already know. Anyway, so those are some of our calculator techniques, and we'll start looking how to solve the problem next.